Alright, so we're gonna get some paper, go over some basics, and let's see my basics setup. I just moved back in, back with my roommate. I think that's right. I need to do this translate this to a computer, but I'm doing as much as I can with paper and pen just to prove a point. Don't need technology to figure something out. Simple logic set. I got a little bit of water. I'm gonna pause it and get some more water and paper. Alright. So one sheet at a time. This is what we're working. 1, 2, 3, 4. Okay. Without any understanding, we know 1, 2, 3, 4. Left hand. So we also know L. Okay. And then I also showed E. Okay. And that's a basic understanding. I also said that A is the infrastructure set for the rest of the alphabet. B, C, D, because that is a kilt with knees, and it needs its feet to where F, and that's, but all straight vertical ones, it needs a pair. So I want to jump, skip, and then the next two is K, L, and then P, Q, R. So that is A. So with that being said, we got 3, 2, 2, 3. This I'm not able to explain yet, but we'll get there. What you need to know is that binary for 10 ones in a row. I got to look at the camera as well. So 10 ones. So 10 base 2, 10 of 1 base 2 equals 10, 23. So Contact the movie with not Sandra Bullock. And God, I'm stuck on speed for some reason. Let's say I want my coffee. But anyways, they say in the movie, the Carl Sagan book, which it didn't translate into the movie, they looked in pi, base 11, and then there was 10 to the 20th, and then there was a series of ones and zeros. All right, you see this? If you know binary, then you know that 1, 1 and base 2. I'll do it this way. Base 2 equals 3. So altogether as a unit, you've got 10, 23. So they're just re-illustrating the idea. So I'm trying to re-teach a different concept. So that's one. Taking this, which you have 1, 2, 3, 4, which 4 in binary, so let's double that. So the way binary works is real simple. You only can use 2 digits. It's 1 and 0. So 0, if a 0 follows a number, whatever your sum total is. So we got 3 right there. If a 0 followed it, so if this was a 1, 1, 0, you would multiply this sum total 3 times 2. So then that would be 6. So this would equal 6. If a 1 followed that, so I'm just going to take it one step further, keeping our same logic, put a 1 there. It is times 2 plus 1. So that is 12, 13 equals 13. All right. Which, as you know, in pi, 13 characters carries you to the 7. So it goes 0. And a lot of times you don't have to write that. The first iteration, and I covered that in the base concepts, and I'll go ahead and reiterate that. So when you talk about a base, like base 2, base 4, base whatever number you got, base just do 63, just because that we're stuck on that concept right now. You will use numbers 1 through, or it's actually 0 through 62. Okay, and then once you hit that number, it's 0, 1, 0, 2, 0, 3, etc. all the way down to get 0, 6, 2. The next one, the next number in the set is 1, 1. No, it's actually 1, 0. It's flipped. And then 1, 1. But this would actually move up. So technically you got 0, 0, and that helps out. So it's 1, 2, 3. So you get to 162. etc. It jumps to the next 10 spot, which would be 2, 0, 2, 1. Simple pattern. Okay, so that's what we do on the base 10. So we'll go 0, 0, 0, 1, 0, 9, 1, 0, 1, 1. So this is our key set. That's our key set of understanding. One thing you got to understand that I don't have a concept just like this right here. All right, which this should be if you write like I write. So I write a 6 and I kind of come over. If you flip it over, you can see it looks like a 2 on the outside, but you're not supposed to know that little trick. Again, with the 7 as well, the 7 is for a Z. And then you go to, if this is A up here, you just highlight and color in those cells. So it's A through Z. That's the last column. So there's 26. And then you go from here to here is 26. And this is straight diagonal. If you go to O and do not add, you just label this number. So row 1 is completely taken out. Row 2, you then place 2 there, except for the one that's highlighted. But you go to row 0 and you do a summation, the full total of 2 through 17, I think it is. I don't know what the number is, but anyways, that equals 65. So, and then that brings you back to that, and that. Whereas 1, 2, 3, 4, binary of 1, 1, 1. So it's base 2 equals base 10. We're just going to put a 10 there just to keep it simple. It's 15, and the 15th letter of the alphabet happens right there. So it's your clock dial understanding. So we got that, and that's why I put a line there. It indicates right there. It moves this line here to understand the difference between a base conversion, which I just posted a video two ago, which was guys. So this is 122. You translate that in base 10 to base 15. The output is 82. All right, and then this one as a unit is base 14. Now you can do this with any word or any movie or any concept. Then carries over. What was it? Anyways, you would type base 10, so that'd be 90, and the output would be 126, I think, or it's vice versa. I may get that, but that's A to Z. We're not to that point yet. But you can do this with any word, any definition. People say that the definitions were. I'm not having that argument. No, I'm correcting this. We're going back to that concept. I'll start over with a new piece of paper. All right. We got 1, 2, 3, 4 on one of our workable hands. So we don't know anything. We just know we got 1, 2, 3, 4. All right. Now, if we place that into a spreadsheet, we're going to make a spreadsheet out of this. So it goes 1, 2, 3, 4, 4. All right. So we got that. And then from there, we have 2 units. So the secondary unit, now I want to show you my bottom side, You got to get your hands up in there to hold the weight. Because a lot of people have your butts, and anyways, I'll hold it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 8 of them. So what I'm going to do, since each digit is represented as 3 measurements, I'm going to go ahead and change that to that. So I got 3, and then this is 1, and that's 3, 2, 3, 3. Oh, see, that's my brain. I'm on 4, 5, 6, 7, 8, 9. So this is 1, 2, 3, 4, 5, 6, 7, 8 of 3s. All right, so I'm just going to go ahead and get that in there. 3, 3, 3, 3, 3. So and then I make the jump, the tetrahedron. Like when you look at it, it sort of looks like that. But if you view it from the top, I'm going to go ahead and just arch that right there. This is at a different level. So that then goes, and then it goes like that. So that and that. So that's how it looks. But when you look at it from this, and that's kind of hard. I've done that multiple times. Look up the tetrahedron, watch it as it spins around, and you'll understand. Basically, it forms 2 triangles from two squares. Well, you can see 4 triangles from each angle, but this line is different from where are we at? This line. They're different plateaus. So the way it works out, you got a 0, 0, 0. So it's 0, 0, 0. And this is 1 dream, 0, 1, because that's a Z. All right. And then, how does that work out? I don't know. All right. And then this goes diagonal. So that's 0, 0, 0, 1. And that's 1, 1, 1. That's the full potential. And then 0, 0, 0 doesn't have any. So I think it may go like that, where this is a measurement of 1. So it's 100. It's 100. I may have them backwards, but this is 0, 1, 0. But you get it. Where the Z is a different platform. So that's your 4 corners of that functioning item. So we'll just do 4C. All right. Because I'm seeing into the future using the pi logic. All right. So this tetrahedron has a measurement. If you do, and I'm going to just jump to this, if you do a pi calculator, geometry calculator, you can find online, you can use multiple variations or actually work the math out yourself. But you take 1944 square root 2. I'm not sure if that's how you write it out, but you divide that in half by itself. The sum total would be 1,4. So 44.090815 etc. I always forget that. I think it's like 7300950, but I'm not sure. If you multiply this by itself, so this is to the second, you will get 1944. Now, why is that important? You know, where's the logic in all that? Well, so this is a spreadsheet. We're going to go ahead and put that on there. This is a different concept. We know it is time. If we take 4, that is 12, 12. we now have a basic understanding. So we know that if we multiply that together, that 144, no correlation to that, or that as a concept of understanding. We're just going to go ahead and branch out. But anyways, when you plug it into the calculator, there is this percentage that shows up. If you carry it out to 8 spaces, it doesn't matter how many spaces. It's a continual 3. So it's always going to be that. It'd be C, 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 C. So we got that. 1, 2, 3, 4, 5, 6, 7, 8. So that's exactly where it's at. So then we start in a Google spreadsheet because that's free. Cell 1, you've done the Z. This is column A. You go 1, and then got B, 2, and then I'll do 3. I'll do this. I don't think I should have any more examples, but then you carry that out to 63, which I think that ends at CK. So that's 63 in that box. And then you do a sum total, a summation. So you add all these up. 1 plus 2 is 3. 3 plus 3 is 6. So it's 3, 6, and then 10, etc. And that's very important because that brings you right there, etc. until you get here. And then in the CL column, you have your total, which is 2016. Now that is a synchronistic idea with the clock. All right, where we have to incorporate, there's different ways you can do this. Like if you did one before, it'd be TO and then TP. But anyways, tater tot is not appropriate because we're not eating this shit. Clock, it's a crisscross. Whereas that point is 63, which in ASCII is the question for 2016. And then from there, you can just do math until we get to our future date, which is 2026, which is 10. So that's 10. I mean, I can count it out if you need me to. But then that starts, you would do 3, 6, 5. I think it's 3, 6, 5, 3, 6, 6, 3, 6, 5. Now, I'm not sure where the leap year happens, but it's in there in the 4. I know that sum total, and I've breezed over this in the video, is 1, 4, 6, 1. So we're doing the end. So I'm going to do it from top bottom. 1, 2, 3, 4, 5, 6. So if I flip that, I'll have to flip that. So this has been used as the sequencer. All right, so now we have 1, 4, 6. So the foundation starts 1, 4, 6. So if we add that up, it is that total. And then 1, 2, 3, 4. All right, which we already used in the counting. So it's 3x, 3, 6, 5, plus 3, 6, 6. This is not how you're supposed to write it, but it's short and dirty. 1, 4, 6, 1. All right. Now you're like, well, how does that work? Well, you then go back into your alphabet understanding and understand that the shapes themselves need definitions. You need to find the arc, which I've already explained that this interior line and this percentage of this angle right here is 26.57 or 26.565 when you're working with pi. So pi, which is to the 13th character, 03.14159.26535. 8, 9, 7, 13th character, which brings us back to the original conversation. But there's 9 right after that. So it'll tie together. I'll show you. So if you do a vertical stack, then so row one. So if you elicit a day, so 01, 01, 20, 26. So A is position 1, so we're going to label that as A. B is position 2, so it gets 2 days. It goes B, B. So it gets 02, 03, Jan, 26, 26. Okay? And the next one is C. It gets 3, C, C, C. 04, 05, 06, etc. All right. When you get to the final Z, the 26th Z, the 26th day label, that day is going to be 3, 5, 1. Okay? Which we've already discussed right here. It's in reverse, so you'll have to reverse engineer this number to make it look like 3, 5, 1. And then you take a normal year, you subtract 3, 6, 5, and you can do it the other way to keep a positive number, but that equals 14. 14. All right. Now, what about a leap year? 3, 5, 1 minus 3, 6, 6 equals 1, 5. All right. And then we're back to the 9, which we're discussing. I don't know where. I know I wrote that down. Where right here. So that's 0. This is absolutely nothing. That's point. That's the point. All right. And the point is, if you go base 4 of 8 threes, 8 to the third. All right, it's backwards. I don't know how to write that there. But if you do this number set into base 4, an output number into base 10 is the restriction for my squirrel. It's 6, 5, 5, 3, 5. All right. So it's 10. All right. So we're caught up there. Confused myself with these papers. All right. So we've dealt with that. So this is technically 3, and then it would branch off that way for the 9. So it's IC is not even on. It's no way you can, because every time you add a new column in front of A in Google Spreadsheet, it's going to rename it A. It's going to keep doing that. So you got to ignore separate concepts. Time is separate. It is literally hands on the clock. You got 12 and 12. We've already discussed it. 12 and 12. All right. And then you can think of it, because I'm just showing you this is technically that. And then this is your folded thumb on top of your folded thumb to make a square. All right, 4. We know that as the restriction property for whatever I'm trying to argue here. So that is I think it's character, or it's a row, cell, something or other in MySQL. Okay. So let's start over. Gotten to that point. So if you took one off of here, I think that's right. If you go to 62, so we'll just go something new one. 2016 minus 62. 2016 plus 64, 0, 8, 20, TP, again, TP. And then if we add another 65 on there, 65, because that would be a logical place to start, because that in ASCII equals the character A, capital. So it's the lowest key cost that you've got of an actual letter of the language. So that's 5. 4, 2, 1. All right, since we're talking about ASCII there, that's the total. You need to understand that 45 in ASCII is. So we got 0, 1, 2, 3, 4, 5. All right. 4, 5 is the minus symbol, or they say dash. Okay, additionally, 4 and 5 can be reinterpreted, if I'm right, as 1, 2, 3, 4, 5, 6. Which, as you're looking at from my watch, looks like a P, and that's the 16th character. Okay? Are we understanding? I mean, you got a smaller, which is divided by 4. And literally, you can make the argument 4 times 4 is 16. All right? So let's go ahead and do this one. I forgot what that was. Is that right? No, you said it's 3. I did that wrong. Because we're removing, I'm just jumping around. I'm sorry. So we got 3, and that's 11, so that's 5. That's 9, 1. And then you would do a 62 from there. 62. It's 1. And that brings you into 1800. So you carry 1. So 1 to 8. It's right over the mark. 9, 1. So, and I was born in 1981 on 10/23. There's the alarm. So I gotta speed this up. All right. So if you connect the 1944 to that cell of CK, because you can suck it, this would be 9 minus column A. Literally, where we took 4 and then 3, it takes us 1, 2, and then to 9, 3. Okay? Now, here's the kicker. If this is O, that's our base count. So I'm going to redo this. So 4, 0. Which is 2 concepts. This shape here is 4, and this shape here is 4. With that whole concept is 16. All right. Then as a unit, you got 1 through 9 as we'll do an infinite symbol there. Infinite symbol of C, 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 etc. So what I'm trying to elicit, like you can do this either way. Like this is a literal 0 through 8 in programming 8. In programming 0 is 1, but 8 would be 9 then, so this would be 9. So if you go into pi at position 40, it literally says 1, 6, 9, 3, 9, 9, 3, 7, 5, and then you search that. 169 happens at position 40. You then search that. That happens at position 70. You then search that. 96. etc. It just keeps going. I think it's 3, 6, 6, something. I think 7 maybe. Which I think that pops up. I can't search. I don't have my other phone. There's a number that I think it's 366 something, but that actually comes into the tetrahedron because this is the length of. Oh, FYI, 80 in ASCII is P. The 9th letter in the alphabet of English is I. And we got 1, 5, 3, and that is the line length, or it's labeled something. Then the height equals 36, and then there's another number that does 27, and then there's another number that does 9, and then there's 3, 2, 3, 4, 6, 7, 8, because we did it to decimal digit 8, so point, so it's 3, 4, 5, 6, 7, right here. That's as far as it'll go. I mean, it can keep calculating. It's going to be 3 through 3, but that's just to tie in the entire conversation. Then we've got 3, 6, 6, I think 7, and then it does a percentage after this. But you take that right there, and this should tie the final thing in. If you subtract, I can get that number. It is 1461, which we know is a full leap year. And then we subtract, I think it's 365. And then we do another one, which is 1 year. And then we do 1461. That's full leap year. So the whole point was is you're trying to get to the length. I forget what the length was, but square root 2 was a number. If this is a measurement of 1, so this box, this is a measurement of 1, that's a measurement of 1. This hypotenuse right here, which represents, this, so it's a measurement of 1, and then this, which technically you can't do because that's the key on this. We have in the predicate before column A 1, 2, 3, 4, 5, 6, 7. All right. We then, this is not going to be pretty. We have F, so that takes care of that. F. Then we got E. Now, this was in a prior video. I'm probably going to link it. But if this is supposed to be the hypotenuse there, so we know this is a measurement of 1, that's a measurement of 1, that's a measurement of 1. So we know the number needs to be 1.41 for ETC. 15.3, I don't know. I forget what that number, I used to know a longer digit set. Anyways, father time, it's me, I think. 1, 3, 5, U, 2, U. I think that's right. Again, I can't catch. The only phone I got is the one recording. So, but this takes 2 cells, 2 cells, 2 cells, 2 cells, 2 cells, 2 cells to make 1, 2, 3, 4, 5. So it's 5. And that's the 5th letter of the alphabet is E. This is actually 6. So it's 6, 6, 6. So, but technically it's 1, 2, 3. So base 3 of 2, 2, 2, 2. Translated to base 10. And I forget what it is. It's important. The other one is 3, 6, which carries in this right here because there's 1, 2, 3. So it's base, and 6 cannot go on to base 5. So this is base 10. 6, 6, 6. Or I think there's another one where it's base 4 of 6, 6, 5, 6. So it's an inverse of 2026, if I can find it. So this is actually, it's 6, 6, 5, 6. But I think that's translated from base 10 to base 4. Base 10, so this one is base 5, Then we got base 4. And this number is from base 10. 6, 6, 5, 6. Now you may have to stroll through the bases. Just get a conversion app and stroll through it. Or you can go to numberempire.com/ and then you type that number. Their site's really cool because each page is listed on the number of information and they just talk about numbers. But there's a lot of information, logarithm, there's calculations, like it'll blow you out of the water. You got to learn to focus on what the information you're looking for and just leave it at that. So I'll leave it at that. Okay. So, okay. I had discussed that if you carried through the same concept of the 63, which is a question mark, you just write the ASCII symbols right below it and carry it to 122. You will have hit 5 iterations. It'll be 26 times 5. Which I discussed. How do you figure out your calendar? Now, technically, in 1752, March used to start the March used to start the calendar year. So for your 31, both hands identical, side by side. All right, which makes more sense. So this started the calendar year: March, April, May, June, July, August, September, October, November, December. Because these 4 right here, the burrs, I think it's Latin maybe. It literally says 7th month of the 7th. Or no, it's a 7th month, 8th month, 9th month, 10th month. So December, decimal. And then we shifted this to the end. All right. So we went from front to end. But with this logic, with keeping March here, then this pattern, you can easily see it. It backs up again because then you got January and then February is the odd one out. So it's literally, if you do that, it's the second finger, 8th one. So if I count from this side, 1, 2, 3, 4, 5, 6, 7, 8. No, 0. It's programming. 0, 1, 2, 3, 4, 7, 8. And then a different counting method is starting with 1, 1, 2. So that gives you that. So, but anyways, again, we're not supposed to discuss time. So, I think we've done it. I don't know. I'll go over. That equals 130, and then tiny z is 1, 2, 2. That's the tiny one on the line. It's 1, 2, 2. Subtract that, you got 8. So at the end, you got 8. Before column A, we have 9. So together for 98, for lowercase, 97 is A, 98 is B. So, anyways, and then it then breaks it down. I forgot what my argument was there. There's no argument, by the way, but I know that it carries us back to 2. So we have 1, 2 digits, and then 12 and 12. So it's 2. It's 2 iterations, 2 counts. So of Z, and then you got 8. I lost my train of thought. I literally lost my train of thought. Oh, well, I know this. I forget what the jump skip point is, but if you take 131 divided by 2, it's 65. So there's 2 of them. So it goes A. We know A is 65. Starts there, and then B, 66. And then that carries that into our 1 logic in reverse. But this is A. There's 2 of them. So we were discussing the cell format for F, F, F. I did that wrong. E. That's not supposed to be there. E. All right. Which I explained in the first reading. So this is 1 right there, talking about C. And then this is talking about the next step. Then we get into K, which I've explained as 1, 1. So the reason why K stems up below the halfway point, because this is a degree marker. Like, you can calculate it however you want, but every 1 hour gets 30 degrees. So that's 1 hour. In that hour, every minute has 360 rotation 60 times. And in each minute, and it always goes like that, 360 rotations in every second, and there's 60 of them. So it's that times that, and that times that times that. So, but that literally 2 are working at the same one. And then, as we know from the beginning, right here, right, that is 3 on a clock, which is 0, which takes us right here. So altogether, it is a huge concept of time, which could be described like that through your mouth, because you're communicating a conversation and sharing a handshake with a statement and a period of divided interest where you get to choose. And then it all goes down into numbers. So sorry about the long video. I tried my best. Let's go ahead and do it this way. I used to do is flip that. Pause and look it through. There's that. There's that. It's really not much there, but I'm not going to explain the whole how the pi expansion happens. I may not even get through the 20 thing loop, because at this, you keep doing this input. At 20, it'll loop back to 169. It brings you back in. But those are key items, key concepts. So because we have 10 fingers, 10 toes, and it goes from, if I do 10 iterations of 26 is 260. If I subtract 20 from there, 20 is 2400. 240, and we have 24 hours in an entire day. 12 of that. So I hope that makes sense. So, yep. So that's 5 iterations of 26, 5 iterations of 26, and you end on the lower. So they're counteracting. So this is 31, that's 30, that's 31, that's 30, that's 31, that's 30. No, the ones with the lines are 31s. They're identical, so it just fans out. That's how we do our division. And then if we have to go over, it gets counted from 0 from this end.